All right, good afternoon or good morning or good evening whenever you're watching this, and welcome. So today's lesson focused mainly on understanding the concepts of a graph. Okay, I actually changed the lesson a little bit, so it doesn't look nice up here, but I kind of drew lines in. So if you guys don't have access to this online, this is what, I didn't put a copy of this online, but this is what we're looking for. Vertex, axis of symmetry, zeros, range, and domain of all of the graphs on both sides. There are 2 pages here. We also want to go into a couple things about the vertex form and standard form as well. And so my main goal for you guys was to actually go beyond the scope of easy, but stay in the realm of understanding where we're at in terms of knowing and doing the basic math functionalities. Okay, so we actually started today in class on the back side, but today I'm going to start with the front. Okay, so what we're shooting for is this is vertex form of an equation. Okay, vertex form is f of x equals a, and then it is x minus h squared plus k. Okay, that is vertex form. If you want to write on your paper, you can, vertex form, but we're going to definitely write this on the back side. And then there's called standard form. Standard form is what we're used to. Okay, standard is the ax squared plus bx plus c. All right, that's standard form. That's kind of where we're going back and forth to. So the front page is 4 graphs. Okay, on those 4 graphs, we're going to take those 4 and we're going to make them into, we're going to plot them out, and then we're going to make them in standard form. You're going to want to use decimals for this lesson as well, just to make sure you guys understand the main concept. Sorry, I was making sure I was recording. All right, so vertex form. All right, I know what vertex form is on the H and the K. Okay, the vertex here. All right, so I got vertex. I've got axis of symmetry. I have the next one is the zeros, the range, and the domain. I will give you guys everything but the zeros. You're going to use decimals for zeros. I don't want to jump into decimals right now and do that. Vertex. Vertex is the HK, so the H value is 4. But remember, it's supposed to be x minus. And if it's a plus here, that means this number here has to be a negative to change this negative into a positive. So I know I'm going over 4 here. Plus, if you look at how the graph is situated, you can only go over 4. And then the K is, so it's -4, and then the K is 3, right, which is the Y value. So I go -4 over up 3, so there's my vertex. And then we had talked about in class kind of just giving a rough estimate of where you think this graph is going to go. I'm not too concerned about the shape, but you do actually on this one have some zeros. So axis of symmetry is x equals -4. Okay, it's the same value, -4, as this. So if I were to plot it out, I'd have an axis of symmetry that cuts this in half. My zeros, graph it on decimals. I think one is a -2.78. Don't hold me to that. It might be 3.8. I'm not sure. But I know the other one's a -5 point something as well. So look those up. Range. Your range value is always with the letter Y. So it's always going to be a Y, and the Y is vertical. So vertically speaking, we go up, or we're going up until we hit this point right here, which we know is 3. So then the question becomes, what is greater? Are the Y values going to be greater, or is the number 3 going to be the greatest value? And of course, on this, going vertically speaking, the number 3 is going to be the greatest value, because every other value is under the number 3. So this is your range, and your domain is always all real numbers. Now, this is only associated with a quadratic equation, okay? Now what we want to do is work on getting this into standard form, which is the ax squared plus bx plus c. So what we want to do is focus on this piece first, okay? X squared plus x plus 4 squared. And what does that actually mean? If you guys remember, okay, x plus 4 squared, all right, what does that mean? That means there's 2 of these. So it's x plus 4 and x plus 4, right? So there's 2 of them. How did you guys used to do the distribution of it? Remember there was the FOIL method, where you would take and you FOIL it out, because what we want to do is create a trinomial or a standard form that looks like this. So we have the x squared, the bx, and the c. We have to create that with here. Most of us in here honestly used the box method, if you guys remember. Okay, so the box method was x and 4, multiply it out. So x times x is x squared, there's a 4x, there's a 4x, and then 4 times 4 is 16. All right, then what you would do is you would write it out. So this is going to be x squared, 4 and 4 is 8, plus 16. Okay, that's what we got. Now there's still a bracket around it, because we're not going to get rid of it, because we need to go back up to the top and put our remaining pieces on there. So in front of this, instead of writing it x plus 4 squared, we had to multiply it out to get this trinomial here. So we still need the -2 and the 3. So we need to add in here a -2 to multiply in the front, plus 3 on the back end. Now you distribute, right? So when you distribute, you just take this bad boy here and you multiply it out. So it's -2x squared minus 16x minus 32 plus 3, and your final equation is the same repeated steps, but these two added together, which would be -29. Ladies and gentlemen, that is your standard form equation. That's what I want you guys to practice on today. Okay? All right. Next, if you guys are struggling with this, please let me know. I'm going to do number 3 also. I did not do this one in class, so let's focus on that. So we start my vertex. Okay, so vert, axis of symmetry. I'm going to just put in an AS. My zeros. Okay, hopefully we have some. My range and my domain. Range and domain. All right, so let's work on these. My vertex is a 3, which means this is positive, so I went over 3. So I know my vertex is a 3, and it's a 2, so it's 3 over 2 up. So here's my vertex right here, which means I'm going to be doing something like this. Once again, axis of symmetry is x equals the x value of 3. Zeros, graph it in decimals. Wherever they are, right here, I don't know, put them down. Range is always a y, and it's going to end with the 2. Okay, so we always know that the vertex point has the same, and the range is the y. So what you have up here, ladies and gentlemen, is make sure you understand. When you go up, okay, you're starting right here at this point, and is every value of y going to be greater than or less than 2? Of course, it's going to be less than, so once again, we have it opening like that. And the domain is all real numbers, but what we're really here for is changing this to standard form. All right, so now we're going to do the box method. Again, there's your box, weird box, sorry. X, -3, x, -3, multiply it out. So I got x squared, -3x, -3x, negative and a negative is a +9. Okay, so here we go. -3, bringing this down, bracket, and then it's going to be x squared, negative and a negative, -6x. So because these are, once you're inside the box, you're adding. So -3 and -3 is -6, plus 9, and then it's going to be plus 2 on the outside here. Now I can just put it all together. All right, multiply it out. -3x squared. Negative and a negative is going to be a +18x. And then negative times this is -27 plus 2. So I'm ending with this equation. So what this does is this allows you guys, there's no quick way to go from vertex to standard. But there is a quick way to go from standard to vertex. And I'm going to show you that technique right now. All right, so I'm going to do 5 and 7 on the back side here. And then you guys will have to do the rest. That's 4 of them. Hopefully you guys make sure you get the rest. So what I wanted to do is let's focus on number 5. We're going to graph this. And actually I'm going to focus on 6 and 8. I forgot. 5 will get you a little bit confused. I'm going to focus on 6 and 8 instead. Sorry. All right, on number 6. First thing you do, graph it in decimals. Okay? This is the fastest way to do it. Graph it in decimals. Here's your graph. What is my vertex? -1, 3. Okay, so if I go back in here, my vertex is -1, 3 right there. So I will go vert, -1, 3. from there, ladies and gentlemen, you kind of know what are we looking for now? Axis of symmetry. The axis of symmetry on this, okay, let me draw this real quick. Axis of symmetry is going to be AS is x equals -1, right? Because that's the line that would be vertically speaking through here. Zeros. Are there any zeros on this graph? The answer is no. There are none. Okay, because this graph does not cross the x-axis. Sure, it crosses the y, but we don't care about that. We're talking about the solution, the x's. So knowing that, if I were to do the quadratic formula with this problem, what would end up happening is the square root part under the b squared minus 4ac. Under here, this is a negative number. Okay, and if it's negative, then that means it's no real solutions. Okay, so I do know that aspect. Range is y, and then it's a 3. The question is it which one's greater? Well, in this case, it's the y, right? Because here's through 3, and it's every value greater than, vertically speaking, of 3, and the domain is all real numbers because this never stops going left to right. All right, all real numbers. All right, so now what we're going to do is we're going to write this in vertex form. Remember, vertex from the front side is f of x equals a x minus h squared plus k. And remember, standard is ax squared plus bx plus c. Okay, these are already written in standard form for you, but we're going to change it into vertex, and that's what's down here. We're going to put vertex form right here. By looking at these two equations, what do these share in common besides the letter x? Well, if you look at them, they both share the same letter a. So what that means is that this letter a right here is actually the same thing that begins with the vertex form. So it's f of x equals a, which in this instance is 2. And then it's always x minus. Now, it's always x minus, but the value of this can change depending upon my vertex. And remember, my vertex here is hk. So if I know that this is the h value, if I plug a -1 in right here, what happens to this? This turns into a +1. And then, of course, it's +3. And ladies and gentlemen, there's your equation. Simple as that. Okay, so hopefully you guys understand that setup. If you don't understand what I did, rewind the video and watch it over again, please, or follow along on number 8. Let's see if we can do this again. Okay, -2x squared minus 4x. I do not have this one ready. One thing I wanted to bring up about number 6 still. Here's our original equation, and then here's our solution. If you guys watch the color, hopefully it'll come through on the screen. You should see as I turn this on and off that it changes colors. And the reason is because it's the same graph. If you graph your original and then your modified vertex, and it's like somewhere off over in here, then that means your points are wrong on your vertex, and you need to go back in here, okay, on number 6, we would go back in here and check our math and make sure we did it right. So always double check your work also by just throwing in decimals, and I mean you can do it within 10 seconds. Once you guys get used to typing it up, make sure you do it to double check your work, okay? All right, so on here, number 8 again was -2x squared. -2x squared. And then, instead of me switching back and forth, and I have a bad memory because I can't remember already, minus 4x. And then it's plus 2. So there's my equation there. Let me turn these off. All right, so my vertex here is a -1, 4. Nice. So vert, -1, 4. Okay, and then axis of symmetry is x equals -1, right? Because it's this value right here. And then what is the zeros? The zeros in this one. So I'm -1, 4 up right here. My zeros on this one are going to be 2.4 and 0.4. So let me go in here. Zeros is -2.4 and 0.4. And so if I know 0.4 is right about here, and I know 2.4 is right about there, so I missed it. I didn't even miss that. All right, so something like that. Nah, I'm not an artist. And then What is my range? Okay, my range we know is a y, and we know it's 4 because that's what's in the vertex, and it's going to be every value that is, and I did that wrong because I'm going too fast. Range is a y into 4, but 4 is the greatest number. So that is the actual right way to do it. And then domain is all real numbers, okay? All real, okay? So make sure you guys have this setup. Now let's change this to vertex form again. Okay, remember vertex is f of x equals a. Okay, my a value is -2. And then it's x minus. In this case, it's once again, -1 is the vertex, so negative and a negative is a +1, and it's going to be +4. Double check the work to make sure we do it right. It's ironic, I thought I picked points that were different. Darn, that one's really close. So that's another setup. Work on these, okay? Turn this in on Monday. This one and the other one involving quadratics needs to be done by Monday. I'll put those in. Ladies and gentlemen, we'll start our midterm review on Monday as well, which will be March, today's the 4th, okay? Once we start working on that, guys, next week is it, the last week before spring break. I'm excited for spring break because I get to work on college work and finish it up. But for you guys, I want to make sure you guys are ready to go. We can rest during spring break and go from there. But before we rest, we've got to work. Guys, this is it, coming down to crunch time. All right, make sure you focus on this. If you have any questions, work on all of them. You guys can see down to 10. If you don't get access to this, you guys don't necessarily need to graph it, but you need to remember if you don't have this, you can write these equations down. Just know what I want from you. So if going on here, if you don't pick up this paper from me in class, okay, know that you can write down question 1, 2, 3, and 4. Just convert them to standard form, and then on the rest, when you go to the next page, on 5, 6, there's 7, 8, 9, and 10. That you guys go in there and you change those to vertex form. All right, you don't necessarily have to graph them. It'd be helpful so you guys understand what the graph looks like if you don't have this worksheet and you want to work on it over the weekend, because I had quite a few students out today on Friday. In the meantime, guys, it's been a pleasure as always. Thank you for working so hard today and yesterday, and I want to say it's been fun, but let's keep to the grindstone and let's finish off this quarter fantastic.